Once again, hearty welcome to the Math Revision Made Meticulous video series on today topic relations and functions, and the subtopic is types of functions. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answering are supported by the ideas used for getting the answer. Before we start, let us see what do you mean by a function, which you have seen it in class 11. Function is a relation between two non-empty sets under some condition. The condition is the elements of the two sets are connected or related by the function, and the left set is here and right set is here, and they are connected. Now you are just seeing how they are connected, and the left side is called domain and the right set is called the codomain, and the elements in the domain are pre-images. The related elements in the codomain are called images. And I am taking another example where I take countries in first set and I am taking their capitals. All of you can connect now. Mongolia will be Ulaanbaatar, Russia is Moscow, like that. Here the countries are related with their capitals, and no country is without capital. You remember that there is no country without capital. All the elements in the left hand side set are related with the elements on the right hand side set. And if you take country and currency, and here you are seeing over here the countries are related with their currencies, and euro and dinar has no pre-image. That is allowed. On the right hand side, euro and dinar has no country in the left hand side, which we are able to connect. Therefore, India and Pakistan have the same image. This also allowed. Now we have seen that every element in the left hand side should be connected with the right hand side set, and two elements in the left hand side can be go to the same image on the right hand side. There may be some elements on the right hand side which may not have pre-images. The rules for a function are: every element of the left set should have images in the right set, and no element in domain should have two images in the codomain. No element should have two images. Suppose this can be very easily, you can remember, if you stand before a mirror, you should get only one image in the mirror. You should not get two images. This is the pre-image and this is your image. And if a man stands before a mirror, you should not get two images in the mirror. It is not allowed. This is not allowed. Well, this is not allowed in function also. Suppose if you take name of the student in your class in set A and your date of birth in set B, all of you know every student will have a date of birth, and if you take the names, every student will have only one date of birth, and there may be two students with the same date of birth in your class. Be careful, every student will have only one date of birth on the right hand side connected with his name, but there may be two students with the same date of birth. Well, now I am taking this example now. Here all the elements have images in the codomain. No element in the domain has two images in the codomain. Hence this relation is a function. I am taking another examples where all the elements in the codomain have images in the codomain, but one element on the left hand side has two images. Not allowed. Therefore this is not a function. This relation is not a function. You have done so many problems in class 11 checking whether the given relation is a function or not. Well, now this is another example to recollect. The last element in the domain has no image in the codomain, therefore it is not a function. Every element should have images on the right hand side. No element should be left out in the left hand side set. Well, now these are the things which you have seen it in class 11. You know how a relation is a function under the condition. That is, every element should have image. A element should not have two images on the right hand side. Well and good. we are continuing. First we will see what do you mean by 1-1 function. It is a first type of function. A function is said to be 1-to-1 if it is if different elements of A have different images in B. It is also called injection or injective. Function is called injective. 1-1 if different elements have different images. Every element will have unique image on the right hand side. Well, if it is 1-1, if A is not equal to B, then the image is also not equal. If the elements are equal, images are equal. Fine. Okay, that you think based on the situation you have to check it out. If f of A is equal to f of B, it will imply A is equal to B. If A is equal to B, it will imply f of A is equal to f of B. If A is not equal to B, f of A will be not equal to f of B. Well, if the pre-images are equal, images should be equal. If the images are equal, pre-images should be equal. That is 1-1. Well, now a function, I am taking one example. Here I am taking over here that all the elements in the left hand side are having unique images. It has only one individual image there, therefore it is a 1-1 function. Well, now here we are taking on the left hand side the first and the last element, they are going to the first element on the top, therefore this is going now, it is having the same image on the right hand side. Two elements have the same image in set B, therefore this function is not 1-1 and it will be called many to one. Many pre-images are connected with a image on the right hand side. Many to one. Finish. Well, now I am taking one example, show that it is f, it's 1-1. Now this can be done by direct method also, or you can draw a arrow diagram that the images of the distinct elements under A are distinct. For 1 it is 4, for 2 it is 5, for 3 it is 6. And if you want to draw a diagram also, arrow diagram also, you are seeing that the elements in the left hand side are having unique images on the individual images on the right hand side. Unique is the general condition, individual is the condition for 1-1. Remember that. Good. It is 1-1 function now. Now, better example is if you take name of the student in your class and exam roll numbers, every student will have an individual roll number. If you take the names as set A and roll number in set B, the function connecting the students with the roll number is a 1-1 function. Your class attendance register is also an example for 1-to-1 because every child is having an individual roll number in the class. Well, it is a 1-to-1 function. Good. Now, what is the working rule? Whenever they ask you to prove 1-1, you take two elements in the domain given. It may be natural number, it may be a real number or anything. Then you assume that f of x1 is equal to f of x2. That is, their images are equal. Then solve it and check whether x1 is equal to x2. That is, the pre-images are also equal. Then it is 1-1. If you are not able to prove it, suppose if you are getting x1 is not equal to x2, then it is not a 1-to-1. Well, now let us go to onto. It is said to be an onto or a surjection or surjective. If it will be called surjective. If every element is of B is the image of some element of A, no element in B is left out. We have already seen that in the codomain, the set of all images are called range. In set B, that is the codomain set, the set of all images is called range. In onto function, range will be equal to codomain. The total range will be the codomain. Okay, if f of A is equal to B or range of f is the codomain of f. Already I told you, is a surjection if and only if for every B in the right hand side set, you will have at least one A in the left hand side set. If it is not allowed means it is not onto. Good. Now I am taking one example over here. Now all the elements are connected now. All the elements in the right hand side are having pre-images. Therefore, this function is a onto function. Here check out. Two elements are going to the same image on the right hand side. Therefore, it is not 1-1, but it is a function and a onto function. Good. Let us go to this example now. Here you are checking that one element is not having a pre-image. Therefore, this is not a onto function. But it is a 1-1 function because the elements in the left hand side, 4 elements, are having individual images on the right hand side. Good. Let us take this example now. I have taken f of 1, f of 2. It is seen that every element of B has a pre-image. 4, 5, 6 is having a pre-image. For 4, 1 is the pre-image. For 5, 2 is the pre-image. For 6, 3 is the pre-image. Therefore, this function is an onto function. I have shown you through arrow diagram also. All the elements of the right hand side set are connected with some elements in the left hand side set. Good. It is an onto function. Better example is name of the student in your class, an exam roll number, and you know that if there are 150 children, there will be 150 roll numbers. Therefore, every roll number will have a student name attached with that. Therefore, function connecting the students with the roll number is onto, as every roll number will have a student associated with that. Well, this is a better example for 1, 1 and onto, because every student will have a unique or individual roll number, and every roll number will have at least one student associated with that. 1, 1 and onto. Good. What is the working rule? You consider y from the codomain as per the given condition. You assume that y is equal to f of x, as per the f of x defined in the given question, and try to get x is equal to what? You try to get x is equal to something in terms of y, and check whether this is allowed in the codomain, domain, whether it is allowed in the domain. For example, domain is a natural number. If x is not a natural number, not allowed. If the domain is a integer, suppose the expression which you got it is not allowed as a integer, then it is not a onto function. Well, then the function is onto, otherwise the function is not onto. If it is onto, means the x which you have calculated should be allowed in the domain, defined domain. Domain may be anything. It may be real number, it may be natural number, it may be set of all integers, and so on. Good. Let us now take one examples over here, and this is every element has an individual image, and every element on the right hand side is having a pre-image. This is a 1, 1 and onto function. If it satisfies both 1, 1 and onto, it is a 1, 1 onto function. It is called bijection. If it is injective, it is 1, 1. If it is surjective, it is onto. It is both, it is called bijective. Good. Now this is another example I told you for bijective. Exam roll number already we have discussed. If you take the students in the set 1, if you take the exam roll numbers in set 2, every element, every student will have a individual exam roll number, and for every exam roll number there will be a student associated with that. But it is a 1, 1 onto function. Better example you can think of. Let us go to questions for revision. This is one question. F of x is equal to 3 minus 4x. Before you start the question, please better identify the domain and the codomain, because they are going to decide whether the given function is 1, 1 and onto. It is from real number to real number. We have to check whether it is 1, 1 and onto. Already we know that what you have to do. You have to take x1, x2 in the domain. Assume f of x1 is equal to f of x2, and then continue. For I am assuming f of x1 is equal to f of x2. From the f of x, it is 3 minus 4x1 is equal to 3 minus 4x2. 3 getting cancelled. Minus 4x1 is equal to minus 4x2. Once again minus 4 can be cancelled. X1 is equal to x2. I started with f of x1 is equal to f of x2. I end up with f x1 is equal to x2. Therefore, it is 1, 1. Let us go for whether it is onto. For that, I have to take y belongs to the codomain. I have to assume that y is equal to f of x. What is f of x given? 3 minus 4x. From this, I have to get the value of x. X is nothing but 3 minus y by 4. Always remember, any real number is allowed only when, in two cases it is not allowed, when the denominator goes to 0, when it is a negative number inside a square root. But here there is no problem, because whatever the real number you are putting as y, you are simply subtracting it from 3 and you are dividing it by 4. Therefore, this will be definitely a real number, therefore no issue, therefore it is an onto function. Therefore, it is both a 1, 1 and onto. Therefore, it is a bijection. It is a bijective function. It's a bijection. Let's move on to question number 2. We have to check from integer to integer given by f of x is equal to x cube. Already I told you, be careful. You should be very careful with the domain. It is assuming that f of x1 is equal to f of x2. Therefore, x1 cube is equal to x2 cube. Now we have to check whether is it allowed for x1 is equal to x2. Yes, it is allowed because it is integer. When the cube of two integers are equal, then the integers are equal. There is no issue. Therefore, it is a injective function or 1 1, whatever may be. Let us check whether it is onto y is a integer. I am taking y is equal to f of x and y is equal to x cube. How to get x? It will be the cubic root of y. But suppose if you take y as an integer, is it cubic root of an integer is an integer? Cannot be. Therefore, x cannot be an integer. It cannot be allowed inside the domain. Therefore, it is not a onto function. So it is not surjective. Injective and it is not surjective. Well, let us go to question number 3. Prove that the greatest integer function is neither 1 1 nor onto. Denote the greatest integer less than or equal to. You know this function already we have discussed. This greatest integer function always maps a integer, any real number to a integer less than it. Well, good. Let us check whether it is a 1 1. I will take two numbers which are real numbers. I am not taking integers, 1.5 and 1.6. What is f of 1.5? It is 1. F of 1.6 is 1. But you are seeing that f of 1.5 and f of 1.6 are equal, but 1.5 is not equal to 1.6. Therefore, it is not 1 1. The meaning is all the elements, all the real numbers lying between 1 and 2 will be mapped to 1. Therefore, so many elements, so many pre-images will have a single image as 1. Similarly, numbers lying between 2 and 3 will be mapped to 2. Therefore, it is a many to 1 function, not a 1 1 function. Let us check whether it is onto. Images under f will be only integers on the right hand side, because only integers will have pre-images. All the real numbers are mapped with integers only in greatest integer function. Therefore, definitely it is no integer will have pre-image. For example, if you take 2.5, it will not have any pre-image. Therefore, it is not onto. Be careful. Once again, I want to repeat. If the domain and the codomain are changed, you may get this as a bijective function. It is a real number to real number. From real number to real number, greatest integer function is neither 1 1 nor onto. Good. Let us go to question number 4. This is a question where natural number to natural number, n plus 1 by 2 if n is odd, n by 2 if n is even. We have to check whether this function is a 1 1 and onto. Well, let us check 1 1. I will take two elements 1 comma 2 which is not equal, and f of 1 is 1 and f of 2 is 1, because from that 1 is odd number, therefore n plus 1 by 2 to be taken. 2 is a even number, therefore n by 2 to be taken. Therefore, you are getting the images are equal, f of 1 and f of 2, but 1 is not equal to 2. Therefore, it is not 1 1. Now, to check onto, suppose if n is odd and n belongs to n, then n is equal to 2r plus 1 belongs to n. It will be in the codomain. Now, I am considering n is odd and I am taking it in the codomain. Then n will be 2r plus 1, which will be in the domain. There won't be any issue. Suppose if there is exists 4r plus 1 in the domain, such that f of 4 plus 1 is equal to 2r plus 1. And now I am able to find, when n is odd, I am able to find a number in the domain so that f of that is equal to 2r plus 1. Similarly, if n is even, all of you know it will be twice that. Therefore, there exists 4r such that 4r, f of 4r is 2r. Therefore, if you take any odd number, it is having a pre-image. If you take any even number, you are getting a pre-image. You are identifying the pre-image only. Therefore, it is a onto. Very interesting question. It is not 1 1 but not onto. Therefore, it is not bijective. You should be careful. Okay, well, let us go back to question number 5, which is from CBSE 2012 question paper. Here, be careful. A is r minus 3, which means that it is real number except 3, and b is real number except 1. And you have been given a function f of x is equal to x minus 2 by x minus 3, x minus 2 upon x minus 3. You have to check whether it is 1 1 or not to justify your answer. Okay, we will justify. To check 1 1, I will take x1 comma x2 belongs to r minus 3, and I am assuming that f of x1 is equal to f of x2. I am assuming that formula which is given in the, I think, f of x expression, x1 minus 2 upon x1 minus 3 is equal to x2 minus 2 upon x2 minus 3. All of you know what you have to do now? Cross multiply. I am cross multiplying and cancelling the like terms. I am getting x1 is equal to x2. x1, x2, x1, x2 cancels. All of you know how to get it. It's not an easy, it's a very easy one. Well, therefore it is a 1 1. Very quick. F of x1 is equal to f of x2, assume images equal, pre-images equal, therefore 1 1. Let us try to check on 2. For that I have to take y is equal to f of x. But remember, y is equal to f of x. Keep it in mind that y is a real number other than 1. Y is a real number other than 1. Well, y is equal to f of x I am taking. Y is equal to x minus 2 upon x minus 3. I am getting what is x now? 2 minus 3y by 1 minus y. Now very quick that y is not equal to 1. We know it. Therefore this x is allowed. If y is 1, this x is not allowed because the denominator will become 0, which is not a finite real number. Well, therefore it is on 2. Therefore we have proved that this is both 1 1 and on 2. Therefore it is a bijection. Well, therefore it is 1 1 and on 2. Thank you. Success is dependent on efforts. All the best.